Hi folks, so question 8 is the trigonometry question. So it gives us this big diagram here. There's two buildings involved. So first question it asks us to work out the size of angle C. So what you should know is that this is a right angle here, so that's going to be 90 degrees automatically. And you know that the top angle is 35, so angles in a triangle add up to 180. So you just need to do 180, take away 90, take away 35, and then that's going to be your answer then. So you should get 55 in the end, so 55 degrees. So that's the answer to part A. Part B then asks us to use the theorem of Pythagoras to work out the distance marked y on the diagram. So back to the diagram then, so we're asked to work out y now. So we're even told here to use the theorem of Pythagoras. So Pythagoras' theorem states that the sum of the squares of the two small sides of a right angle triangle, which we have here, is equal to the square of the large side. So the two small sides in that right angle triangle. So we're looking at this right angle triangle here now. So you can kind of ignore the rest of the diagram for the minute. So we're looking at that right angle triangle. The two small sides of that right angle triangle are the 220 and the 154. And we're asked to find out the long side of it. So the long side of it is the y there. It's the diagonal that's going across. So we're going to square both of them and add them together. And then that should be equal to what y squared is. So the squares of the two small sides. So if you square them and add them together, you can put all that into your calculator. So you're going to get 72116. That's equal to y squared. And then the last bit, you're going to have to do square root of 72116. And that gives us 268.54. And it tells us in the question then to round it to the nearest meter. So we can just round it off to 269 because the 5 means that the 8 goes up. So 269 and meters we should put in as well. Now use trigonometry to work out the value of Z, the height of the building B. So we have to work out this distance here on the right hand side. So we know some of it already because building A there is 220 meters to tell us that. We know that it's 220 up to here where it's cut off. So we know that's 220 up to there. So really what we've got to work out is we've just got to work out this bit here, and then we've got to add it on to 220. Now we know the dotted line going across here is 154 as well, because it's identical to the bottom. So ultimately what we're going to be using here is we're going to be using SOHCAHTOA. So we know that the angle there is 20, and we know that the bottom is 154. If you're to label these then, in terms of opposite, adjacent, and hypotenuse, we'll call this maybe call this x here for the minute. There's no other x's in the question. So 20 is our angle here, so x would be the opposite. That's what we're looking to find out here, and 154 is the adjacent. So we've got the opposite and we've got the adjacent. So opposite and adjacent means we're going to be using tan. So tan of the angle 20 is equal to the opposite, which is x, over adjacent, which is 154. So you need to look back at those three, sin, cos, and tan. So tan is opposite over adjacent. So here we have the opposite and we have the adjacent. The opposite of what we're trying to find out, the adjacent is 154. So because the variable is on top here, we can just move over the 154 or multiply both sides by 154. So 154 times by the tan of 20. And then that's going to give us our answer. So that's what you need to put into your calculator. 154 times tan 20. And that gives us 56.05. So that's the blue part here that I'm shading in here now, shading in red, that we've worked out. So we need to add on to 220 then, because the question actually asks for the height of building B. So we're going to add on 220 to that. And it gives us 276.051. So, and it asks us in the question to round off again the nearest meter. So it's going to be 276 meters. And that's going to be our final answer.